It's actually a very, very exciting day. Val is going to do most of the talking today. I think I never met Val leading up. I just wanted to introduce Val. And my name is Mike. I'm one of the co-founders and the CTO of Gilt. And today, I'm actually super, super excited. We're at the point that we're ready to open source and introduce Cave to the world. I'm going to talk quickly about Cave, and then we have 3-4 slides, and then I wanted to share a story of why we did Cave, which I think is kind of interesting. So we've at Gilt struggled with monitoring and alerting, and we've used all of these things: OpenTSDB, Nagios. We used Xenos before that. We looked at Datadog, New Relic. We use a lot of New Relic at Gilt. We use PagerDuty for notification. And when we think about monitoring, I think a lot of people think about monitoring and alerting together. And one of the things that we've learned is that those two things are actually very, very discrete. And treating alerting as a first-class task or product has been actually instrumental to what we do here at Gilt. And the way we've built Gilt over time is it is a microservice architecture. There's 300 or 400 different individual applications. That's a whole separate talk in itself. There are pros and cons of that type of architecture. But it really put a lot of stress on traditional alerting systems and made it very difficult to understand when individual applications are actually having problems versus something systemic in the system. So as just a concrete example, just on alerting, we also use Zookeeper, or none of the services share a Zookeeper cluster here. And imagine that you have 300 applications in New Relic and there's a hiccup on the network that causes a timeout in Zookeeper, and you get 300 alerts, right? Because every application is going to detect that as a problem. And as developers, we do what we're really good at, and we create email filters and file all those alerts into our trash bin. And so now our alerts are kind of useless. And so the question is, how do you solve that problem and actually have alerts that are meaningful, right? It's a hard problem. We also had this other challenge. How many people here work with financial auditors? You are lucky. So I spent a lot of time working with our auditors at Gilt. And when initially we weren't quite aligned, and it took me a long time to understand why. And fundamentally, at the end of the day, auditors are there to minimize enterprise risk or risk to the business. And it was kind of interesting. It's like, well, I want to do that too, right? Like, who doesn't want to minimize risk? We want to minimize risk of deployment. We want to minimize risk of errors. And the question really comes down to seeing eye to eye and where are the big risk areas that a company faces. And so a few years ago, as our auditors learned about Gilt, they said, you need separation of responsibilities. Says, okay, why? Let's talk about why, and it's to reduce risk. And said, okay, so you don't want software developers to deploy, you want the infrastructure team to deploy. But actually, we don't really have an infrastructure team at Gilt because we have a very small infrastructure team that works on core stuff, but they're not equipped to deploy software. The teams are responsible for deploying software. So how can we have separation of responsibility? And this is a real challenge for auditors, right? Say, well, how are you going to minimize the risk? Because we're going to minimize risk by hiring great people. And great people are going to run their application end to end. And if their application wakes them up at night, they're going to wake up and fix the application so it never wakes them up at night again. And that's the way we're going to run the company, because the biggest risk to our company is if we can't attract great people, then we're not going to be able to innovate and our company is going to fall apart. So our biggest risk is actually attracting great people. So how can we make sure that we continue to do things so that the best engineers in the world want to work at Gilt? And the auditors mentioned this word called continuous. So in the conversation, they mentioned this word called continuous audit. I kind of latched onto that. So what is continuous? And they said, well, if you continuously monitor something, like the number of orders you're getting or how much revenue you're generating, then you can maybe detect errors or anomalies in kind of those things and use that to minimize risk. And so we kind of latched onto that and said, we're going to create something called the Continuous Audit Vault, which became Continuous Audit Vault Enterprise, which became Cave. And the original idea was that we're going to continue to allow our teams to deploy software to production. We're going to continue to encourage our teams to have access to their databases because they need it. They need that information to debug, to make sure that things are running properly. And instead of trying to limit artificially access to these systems, what we're going to do is measure things. We're going to count things. How many orders were submitted, how much revenue was generated, how many orders were edited. And if we want to be really accurate on things like revenue, we can count 2 different sources, right? We can take things off of a transactional stream, we can take things out of an order database, and we can actually compare those 2 numbers. And if there's ever greater than, say, 0.5% change between 2 numbers from 2 different sources, you know, there's something wrong. And we want to know, and our developers want to know. And we can set up an alert for that. And so Cave's origin started as a way of maintaining a developer-friendly culture at an organization at scale, while making sure that we were really diligent about understanding the risks of the business. And over time, what we've learned is it turns out to be a really good alerting system to allow developers to know when their applications are behaving and to get a notification when their applications are not. And in general, it was kind of interesting. We were working with the auditors on the design of Cave. It's like, what do you guys really care about? We want to make sure that developers can't log into the order system and to the Cave database so that they can accidentally make a change to the revenue numbers and accidentally change the alert at the same time. So we wanted to make sure that Cave itself is very secure, it's independent, it's proprietary, separate from Gilt. And actually by making it open source, it's actually great for Gilt because this is a project that we think has it solves a real problem. And actually all the code is visible, and that turns out to be great from an audit perspective. But we designed Cave from the beginning as if it was an application built for a general problem, and Gilt itself is just the first customer of Cave. And then we measure the success of projects like this by how many people are using it, how many alerts are being created, and it turns out that something like Cave solved the real problem. We saw pretty broad adoption across Gilt. And so over the last few months, Val took the lead on really packaging up Cave, improving the documentation, which is amazing, and coming today to tell you a little bit more about Cave. I do want to say, actually I'll say that for a sec. There are a couple, few requirements we had. So horizontally scalable to millions of metrics and alerts. Cave is built on top of InfluxDB, which is a time series database called Dix out in New York. InfluxDB is really provides a nice feature set of functions that you can apply over time series efficiently and compare them. Itself is built on LevelDB, which helps us scale. Multi-tenant, multi-user, so again, Gilt is just one of the customers of Cave. Lots of different individual accounts are set up here. The way we build apps at Gilt is we build REST APIs first, and then build web apps on top of the REST APIs. And that means that when you interact with the UI for Cave, as an example, everything that you can do in the UI is actually available through the API because the UI only talks to the API. I think that's actually super important as well because as developers create different workflows, everything's available through a REST API and well-named, simple to use. I think some of this, we kind of spent a lot of time thinking about the grammar to define an alert. So it's a very simple natural language grammar to let you do pretty complicated things. But you can do things like, I want to compare the average number of orders we've received over the last 5 minutes, and I want to compare that to the 99th percentile over the last month. And if that's different than some value, fixed value, or value coming off another time series, that then is a trigger to alert. And in thinking about the features of Cave, kind of the way we approached it is what we wanted to do was make sure that when an alert fired, developers did one of three things. They delete the alert, not a good alert, just delete the alert. Don't create an email filter, just delete the alert. Or modify the condition. That can make it really simple to modify the condition. Maybe you want a broader tolerance, or maybe you want to compare it to another value. Or three, fix the problem. And that really, like being diligent about that cycle, I think has a lot of value because what it does is it frees us up as developers to stop worrying about whether a system is actually working or not. And by no longer worrying about whether or not a system is working, that kind of frees us up to go build something else. And I think that's really kind of the power of Cave and what we've seen here at Gilt. One of the services that I built kind of 2 years ago personally, it failed. We didn't have great alerting 2 years ago. I missed it. It actually caused an issue in production at Gilt where one of our prices was wrong. Today, actually just last weekend, I got a text notification on Saturday morning thanks to the PagerDuty escalation through Cave. There was actually a production issue, and Cave had been monitoring the service for the last, I think, 9 months. This is kind of the first alert fired since, I think, at least December, and it was real. And so you get the alert, and it's like, wow, this feels great, because I can trust Cave to let me know when there is a problem. I do want to add just one more thing. For me, it's been a real pleasure to work with Val building Cave over the last, I think, year and a half. It's been a while. The highlight, though, is a couple months ago, the team here in Dublin did a hackathon to knock out a bunch of features for Cave. And I remember one of the comments, I think it was John Kenny, made the comments like, wow, it's so easy to contribute to Cave because the code is beautiful. And so it's kind of really nice for us to be able to thank Val for his kind of leadership on the code. We encourage you to look at it. It is actually super high quality code. We're very, very proud. of the software, and we hope that you guys found it useful. So with that, I'd like to hand it over to you, Val.
So now I'm going to tell you how we built this thing. From an architecture point of view, we decided to put all our data in through Kinesis, and you will see why. Basically, all the data goes through an elastic load balancer to API service instances, and these can scale horizontally as we wanted. So you can add more capacity as you need more throughput, and everything then is thrown into a Kinesis stream. And on the other end, I have a fleet of DB writers which are pulling data from Kinesis and spooling it into InfluxDB. So this is all a pipe, right? And why did we decide to put Kinesis in the middle? Is because it makes it very easy to add more data. So as an example there, I don't have this module yet, but you could add a module for predictions that might pull raw data and push process data or another metric. And that metric is going to end up in InfluxDB through the same DB writer fleet. So adding more data to the system is fairly easy through Kinesis. In fact, the API service itself uses the same pipe to push its own internal metrics, internal performance metric, to Kinesis in Influx. So I can see the Cave API metrics in Cave. Right? The API service uses an Amazon RDS instance, Postgres, to store its configuration. All the alert configuration is stored in there. And to evaluate alerts, we have here two more fleets, and they communicate through SQS. It's a typical producer-consumer pattern. And the schedulers are sending alert schedule in SQS. Basically, this is deciding based on your alert definition how often you want this alert to be evaluated. Is going to say, okay, it's time to evaluate this alert again and again and again. So every time an alert needs to be evaluated, one schedule is going to be pushed into SQS. And the workers on the other end are pulling the SQS queue, and they work in parallel, obviously, and pull data from metrics, evaluate it based on the alert configuration, which is all passed through SQS, and generate notifications as needed. We were talking about a pluggable notification. We currently support only PagerDuty, but that could be easily extended. Just very simple interface for sending notifications, and right now we are quite happy with PagerDuty. So, an interesting fact, I was talking about the data going through Kinesis. Every time a worker evaluates an alert, it publishes as another metric the alert history. So basically it's going to say alert with ID was evaluated at such and such time and was found red or green. So it actually valued 0 or 1. So if you want to see alert history, it's just another metric in your system, so you can just plot it. It's going to be on the same graph you see metric data, you can also see alert history. Now the metric definition is very flexible. We have a name and then key value pairs. And we use these extensively. And why, we'll see in a moment. Basically, for the simplest case where orders has just one tag, where is it shipped, and actually we only have US and international because that's what interests us. For more application metric, like more complex application metric, you may have as many tags as you want. There's no limit here actually. And the only constraint you may have is that you don't want the tag values to have a very high entropy, basically not too many distinct values. So this is useless basically to have a tag that has very high entropy, because you will not be able to view individual values. It's not going to make much sense, like for example to put a customer ID in there. But as you can see here, response time is a metric that I publish from the API service itself, and I can publish, like for example, the operation that was executed, the result, and I have a class of results, basically success error, customer error, server error, and so on. What service name, what environment, what host. And the tags are very good, because when you do aggregation, you can do aggregation across tags. So in the first example there, I have orders shipped to US, and I do 5-minute sum. And that will give me only the total number of orders for US destination, but if I don't specify any tags, I'm going to get total number of orders regardless whether they were shipped US or international. Again, for a response time metric, for example, I want to specify exactly what I need, and everything else is aggregated across. So by not specifying the environment in there, I might end up seeing the response time for that service, for that operation, across all my environments, across all my hosts. If I want to be more specific, I want to see just in production, then I will have to specify the value of the tag. So the aggregation is very, very flexible, and you don't have to, you can specify any aggregation you want, so that you end up with all the rollups that you need. We support a large number of aggregation, and actually they are coming from Influx. What Influx offers us, and it's very, very good for this particular system, is that it does the aggregation on the fly. So you may store all your data in raw, and you may get the data evaluated when you want to plot it, just to see what would my P99 look like for such tags. But when an alert is created, we give that combination of tags to Influx, and Influx generates the rollup as data gets pushed. So when you do a get on a metric data, it's going to be instantaneous. You're going to get it immediately because it was pre-aggregated when the data was pushed. So that's one thing that Influx does that you might not get with any other, I don't know, relational database or NoSQL database. It is a time series database, and it does the rollups on the fly because we told them up front that we'll be interested in those rollups. The alert grammar, we were talking about how flexible we want to make it, and this, we support comparison against threshold, and you may have seen this in other systems. But we also support comparison between an aggregated metric and value, sorry, an aggregated metric and another metric. And I don't know if competition supports that. CloudWatch for sure doesn't. Basically, I'm trying to compare here an orders value against another metric that may be like predicted output of the prediction system. So if I am under the prediction, I want to know about it. Another thing that pisses people off is that you cannot generate alert every time something happens. Most of the time, some things are transient. So, like for example, if my response time goes above a certain threshold, I want to know about it. But if it goes immediately after back down, I don't want to wake up to that, right? So most of the times you will end up saying, I want to know if it went above the threshold and it stayed there for at least so many times. And this is a feature that most systems have. But what we have done extra is, right. Sorry.
What try going on the right?
Oh, sorry. So going. The additional feature that we needed was multiplication with a constant. Then we were talking about being accurate, and if my prediction, if I'm okay with being under the prediction but not within 10% of it, I might want to add another constant in there. And this is another special format that we support. If you want to know about a metric being missing, so something hasn't been published, I want to know about it. And we use this extensively for heartbeats. We have services being monitored, are they alive, at every service name and host combination. And you may generate alerts so that you know if a host has gone down or not. And the way we do this with heartbeat is that we actually publish a 0 for OK and 1 for dead, not responding. So you can actually apply combinations like making summation, how many hosts are down for a certain environment, for a certain service. And I might be okay with one host being down, but I don't want to be, I want to know about it if I have multiple hosts down at the same time. So you can apply a combination of the aggregator before say the sum of the heartbeat, if it's above 3, I have too many hosts down at the same time. Okay. Now this is the user interface we built. It's very simple, very clean. It uses the Bootstrap, and as I said before, we have this built as Gilt is just another customer to this, and I actually have 3 different organizations. This is my account. Gilt is, I'm a member of the Gilt organization, but I also have the internal one and the KPI one. The KPI are the key performance indicators of Cave. Like, for example, one of them is how many alerts do I have in the system right now. That's one of my key performance indicators. So I published from inside Cave those 2 groups of metrics so that I can monitor and keep an eye on it as an owner. And then part of Gilt, I am part of different teams, and you have the ability to see your metrics. You can graph them, and in the brackets you have all the tags that come up for those metrics. These are a couple of alerts being defined. These are internal Cave alerts. I have a write-up delay metric that is being published from the DB writer, and if it's persisting data too late, that usually means that there's more data in Kinesis than the writer can persist, and I want to know if it's been more than 3 minutes. So data being published too late, that means it's really bad for Cave, and for all my Cave customers, because they don't get the data on time. And I have another metric missing. If it's missing, then it means my DB writer is down. So I have alerts to monitor Cave with Cave. This is the graphing interface. It's pretty simple, built with a JavaScript library, and you may have seen something similar in the competition. CloudWatch has it very, very similar. You can pick up your aggregation, and you're going to see your graph, and you can zoom in that lower section. So yes, it's open source. The code is available under Gilt Cave, and the docs are published in docs.klc.io. Actually, all the docs that you see on that website are generated from Markdown files that are inside the repo. So everything is inside the repo. All the modules, all the documentation. And here are a few words about the roadmap, stuff that I would have liked to work on if I had the time. Basically, there's 3 things of main interest. One, the InfluxDB version 08 is what we use right now. 09 is not yet. I think they're working on release standard 50 or something. It adds support for tags. What we don't have, and I can show you in this graph here, right? So here I have my tags for my metric. So, but all I can tell you here is what the tag names are. I don't have a list, a comprehensive list of tag values, because InfluxDB doesn't give me that now in 08. In 09, I was able to query what are the possible values for hosts for that particular metric, and I could put a combo box there, a selection box, so you can pick up which host you want to see. Because right now, unless you know exactly the value, you're not going to be able to filter on a host. Another thing that they promised in 09 is improved clustering performance. The InfluxDB 08 is quick on writes, but not so quick on reads. And if you deploy Cave on your own machines, you will end up probably staring at the sprinter when you're reading data for long range. Calatrava is going to be the next offering from Gilt, open source. It's a system that is monitoring the database and publishing events for any changes in certain logs, certain tables. And the Cave is going to use Calatrava when we have it available, so that we replace the messaging that currently happens between the API and the scheduler. And I'm not going to scroll all the way down to that, but I showed you that API writes configuration into the database, and scheduler reads that configuration from the database. Today, it has to reread the documentation, the configuration periodically, because it may go out of sync, because the notifications that go from API to scheduler now are using SNS and SQS, and they're not. I've seen events being missed that were published into SNS but did not arrive in the SPS on the other side, even though the SPS is subscribed to SNS. So the scheduler might end up out of sync with configuration because it doesn't receive all the events from the API. When you change an alert configuration, you might disable an alert and the scheduler doesn't find out about it, still schedules the alert checks. And Calatrava should be a very easy slot replacement for that particular messaging. And finally, the schedulers today, I have multiples running, but only one of them should be emitting events, because only one should be the authority of these are the events that need to be emitted. And the others are just hot standbys. To do so, I'm using AGA clustering. So I initiate the cluster via, I'm finding out from autoscaling what are my schedulers, and I initiate the cluster, and I use a singleton for the actor that actually does the publishing. If we rewrite the AGA cluster so that I can, one thing that doesn't work here is because we run with Docker on top of EC2, we can't use Beanstalk. Beanstalk does not allow my Docker instance to share the network of the host, which we do today to run the scheduler. This is all in the deployment notes. The fact that I can't use Beanstalk, we are kind of struggling with deploying the scheduler. So it's a little bit of an issue. And when we would do that, so we're deploying with this tool called Ironblaster, which we haven't open sourced yet. It makes it very hard to do deployments. And we would like to be able to migrate to Beanstalk. But until we rewrite the cluster bootstrapping, that's not going to happen. So these are the three issues that would definitely improve Cave in the short term. That's about it. So, questions?
Questions?
Yes.
Yeah, just as a matter of interest, did you start off with influx and find that you were building up a set of stock queries and it was worth developing like a little domain-specific language or something on top? Is that where it came from, or?
No, we we wanted something to as Mike described it, we wanted something that would be efficient in that it's fast when you try to evaluate the alerts, right? So the alert conditions, the flexibility that Influx gives was what made us choose this tool for our backend. Does that answer your question?
Well, yeah, I was just wondering if you kind of like had found Influx and went, hey, there's cool time series stuff I can do here. This is brilliant. Guess what we could use this for? Let's pipe all this stuff in here and do our, statistical analysis, and then
we wanted a time series database for our backend.
Yeah.
We had some experience with OpenTSDB, and OpenTSDB is again quick to store data, but pretty slow to get it. And what we liked most about Influx that OpenTSDB did not have was this continuous queries called, where you define it up front and say, this is the data that I'm going to be interested in, rolled up data. And Influx creates that for you automatically. As you pump data into the raw metrics, it creates the rollups for you. So when you query the rollups, the data is just there. You don't have to roll it up again. Whereas with OpenTSDB and other systems like that, the rollup is built on query. So you may end up waiting for a minute to get the rollup for last minute. So it would be slow and inefficient.
I had a few things. And the other thing is, databases are databases, and a lot of developers, I'd say, we like REST interfaces. And like REST interfaces to data, REST interfaces to create alerts is actually super, super important. Do you want to pull up the API docs that you have for Cave?
Yeah.
And the origin of this is, there's a couple different things going on, but like Influx by itself is somewhat raw. And as a developer, you just want to say, I want to create an alert, and here's the condition by which I want to be informed that there is a problem. And it'd be nice to do that in REST. And that's not what there's kind of a boundary there, right? Influx, it does, the continuous queries feature is pretty powerful, scalable architecture, the ability that kind of Val mentioned to compute all of, all the functions that are available that are being applied in real time. You want to go to the, okay, so this is the alert resource. But like as a developer, like, I don't know, post to / alerts seems pretty nice to be able to create the alert that I want. And there were a couple of things I think that we learned over time at Gilt around alerting specifically. One is that alerts work better when applications publish metrics in general. Not all, I mean, there's exceptions, but I think when we started, we always had kind of centralized monitoring that would go out and collect data from all of the different instances and then make that data available. Contrast that to every instance of software that's running is publishing some metric. That second model is pretty powerful. You no longer need centralized knowledge of everything that's running, right? You don't need to know how many. If you're supposed to have 100 nodes or 3 nodes, I mean that's going to depend. What time of the day is it? How much load are you getting, right? If you have a centralized system that's collecting metrics, you need to be aware of those things. If instead you have a system that's publishing metrics, it actually is a simpler model. But then things like the missing 4 or 5 minutes become super important, right? Imagine one of the specific examples of that is like imagine you have background tasks that are running. Now it becomes very easy, like right when you start any task, just publish a metric, task run. That's great. If you want to now be alerted if the task doesn't run for some period of time, that's kind of how do you define that alert? It's like count the number of metrics over this time period, missing for 10 minutes, and you get an alert. 10 minutes is too long, too short. Just change that to 5 minutes, 15 minutes. And that's pretty powerful. And so if we come back again to at the end of the day, if we want an alerting solution that has the flexibility to allow us as developers to say, when the alert fires, I'm going to do something, and that something is take action, right? Not turn off my SMS notifications or create an email filter. What do we actually need to be able to do that? I think that's a pretty powerful tool, right? Like regardless of whether or not you're using Cave or some other system, but this idea that you're publishing metrics, whenever something interesting is happening, just publish a metric. Independently of that, now you can count metrics and you can compare metrics, and based on that, that's pretty interesting. I think Cave, if you haven't looked at InfluxDB, I mean, I think the product is great. Like you look at the aggregations, the ability to calculate, say, 99th percentile in real time is pretty interesting and pretty useful. And then here in Cave, what Cave makes really easy is then to be able to compare a metric value to another metric value is also super powerful, right? Because we found that what's an acceptable response time? Don't know. 10 seconds is probably unacceptable, but you probably want to get an alert before you get to 10 seconds. So but then what is the right response time? How do you filter and tune the alert conditions so that when the alert fires, people are actually taking action? Turns out to be a pretty hard problem. Yeah. I don't know if you want to go through.
Yes.
So, a couple of questions. So, I think the first question is, so how many, let's say, endpoints, how many services do you monitor right now? Yeah. And how many alerts get maybe raised in a day? And can you maybe just show like the alerts that got raised in the last, I don't know, 3 hours, 4 hours? And then the question would be, out of the alerts that got raised in the last 4 hours, how much of them are delete, fix, and what was the third one? It was delete, fix, and
delete the alert, fix the problem, or adjust the condition.
Or adjust the condition.
Yeah, I don't know if are we monitoring?
Actually, adjusting the condition is one thing that is not possible. Basically, if you have a wrong condition, you need to create a new alert, and we have a feature called clone, where you say, I want to clone this alert, you change the condition, creates a new alert, and then you disable the old one. And why you do that is because you basically, by changing the condition, you will alter in the past. So it would invalidate the alert history. You would be looking at an alert history and saying, hey, why did it fire here? Because the condition is
I don't mind as long as it's fast. As long as I can do it in 30 seconds, I don't mind.
Yeah, actually I can't really show you what has fired. We delegate that to PagerDuty. So if I log on now to PagerDuty, I can show you what were the last PagerDuty alerts in the last 4 hours for everybody in Gilt, but and what they did with them. But Cave itself does not keep track of what happens beyond I have created the alert. My KPI today is how many alerts have I evaluated every day. So that's my KPI. You want to see that one?
Yes. How much is it?
I'm not sure, but it should be around 900 alerts.
900?
Well, I was pulling that up. And we talk a lot here about immutable data and immutability generally. We use a lot of functional programming languages at Gilt, but what we learned is that immutability is actually very, very important. And so the ability to not edit a alert, the UI will let you edit an alert, but underneath what's happening is that we're ending the original alert and then creating a new alert to provide the kind of the history of the conditions. This is the 665 alerts in Cave internally at Gilt.
That's counted every day.
How about today?
665. So alerts active was over 800. Oh, so this is the number of evaluations that not. The alerts operations, this is pretty low. This is how many were created.
What are these? Alert operations or alerts being triggered?
No, alert operations, how many times people have created or deleted or edited an alert, but they doesn't say what they did.
Yeah, so people are creating 1 or 2 alerts a day. I think what that shows.
We don't keep history beyond 2 weeks. But this is the influx cluster we have is not very stable. So we keep it, as I said, in 0.9 we expect a lot of improvements on the cluster and stability and performance of the clustering in itself. So we don't keep data beyond 2 weeks' time. Most alerting system will not keep that. So this is not a metric where I can pump metric and keep them for a year and see how I performed last year. Because it's for alerting and when things happen I want to know about it, the past is not as significant, right? So I can't share it beyond 2 weeks history. I would be happier to keep it like 3 months, but my cluster is not so good today, and we're working with the influx. So whenever they make the 0.9 available, we will be jumping on it and try to get it so that we need to make changes to use it. But it's going to give us the stability that we need in order to pump more data in. So right now I'm keeping the history short. This is actually done in influx. Whenever we create a new database in influx, we set the life to be 2 weeks. So they trim the old data on their own. It's just like S3 lifecycle on the bucket. So the data gets streamed automatically. They don't have to go and drop it or anything. So I can only show you the last 2 weeks how many alerts have been, and since nothing new has changed, it looks like it's slow. That's why we're limited to 2 weeks here. That hasn't changed much. 665 alerts per day. Did you see 2 questions? I'm sorry, Roland.
No,
That was it?
that was it.
Okay.
So you mentioned that output alerts are immutable. So if you want to just you started explaining why there are 665, and why there are so many alerts.
Actually, a lot of these alerts are not too different from each other, and a bunch of them have been created via script using a curl command, because via the API, not the UI. Nobody would like to create 600 alerts for the UI, I think. And they are created for specific metrics, so that we see that such and such job has run, periodically. I want to know if it hasn't run, and there are multiple jobs that need to be monitored for multiple hosts. So all that combination, like Cartesian product, generates a whole bunch of alerts that you don't want to create manually.
So these are like this number of alerts, not the number of events triggered by those alerts.
Yes, no. So this is the number of alerts evaluated in every day. So actually, this is a metric that I publish from inside Cave. Every time I evaluate a certain alert, I publish how much it is, and then I have a continuous query that calculates how many unique ones have been evaluated every day. And it generates one data point per day.
Do you have a feel how many alerts are being triggered every day at Gilt? Like actual escalation? Low, right?
It's not that high,
Right.
that's for sure, but I wouldn't be able to tell you because I don't have that published.
So how do you deal with that situation that you mentioned where you have 300 services and there's underlying issue and all of those services see a problem, and how do you prevent firing of 300 events?
Because these alerts will not fire at the same time. They each are for a special, for a certain host not doing a certain job. So
If I had 300 services.
And the other, so the question is really good, which is like, how do you prevent the Zookeeper example, right? Let's say we have 300 services, 300 alerts, and they're all sensitive to something. So I think the question, so how do we prevent 300 PagerDuty escalations from going off if there's a network issue on the Zookeeper cluster? And I think so what's interesting is the question is really like, what are we monitoring? Like, what are the metrics that we are publishing for which we want to get alerts, right? And I think that's actually a pretty interesting question. So for example, so at the risk of starting an argument, like why monitor response time? Because response time doesn't actually matter, right? It just doesn't matter. You really care if it's 10 milliseconds or 20 millisecond response times? Probably, I don't know, maybe you do, maybe you don't, but like, why do you care, right? Are we not accepting orders? Is there a variation in that? Are we not sending enough email? Are people failing to log in from mobile applications? Like, what is the metric that we actually care about, right? Everything else is arguably a proxy for that metric that we care about. So let's start publishing the metrics that we actually care about, and then on those metrics, go ahead and create the conditions. And so with the Zookeeper example, so in practice, a simple one is every time an order is submitted at Gilt, I think there's a consumer that listens to the order stream and then publishes a metric to Cave. I'm looking at Val. Yes, Val says yes. And so, and that's how we count the number of orders that are submitted, right? That's great, because if we fail to publish a metric, it doesn't actually affect the user experience, yet we're still able to count the orders from an independent stream. That's really, really nice. So now we can create a metric that says if, for any order shipping to the US, if we haven't seen an order in a minute, like that's an outage. That actually is how we define an outage at Gilt, by the way. It's like we're not receiving orders, and we're an e-commerce business, so let's do that. So now let's say we have a Zookeeper outage. That's fine. Maybe the nodes running checkout don't receive the latest configuration, but they're still accepting orders. So that's not going to trigger an alert. Meanwhile, the team that's responsible for running the Zookeeper cluster, they're going to be publishing a different type of metric to monitor the health of the Zookeeper cluster. And they'll come up with a way to monitor that, and then that alert will fire. And I think there's a little bit of art in deciding what the alert conditions are. But if done properly, or kind of in that spirit of like, what is the actual business metric that we care about? And let's make sure that we know when that event happens, and we can create a pretty robust environment for kind of monitoring and alerting. And I will say, just in terms of just the microservices, I think there's some of the problems that we've been solving just get exaggerated with kind of the large number of services, right? If you're running a monolithic stack and you have a Zookeeper cluster, and there's an error in the monolithic stack, it's like that's a problem the team has to respond to. So to a certain extent, the alerting is a lot simpler. And so kind of over time, as kind of I think as Gilt grew and as the number of teams grew, is really trying to solve for that. Like let's turn off we can, I think, probably keep the notifications from New Relic and some of the other systems that really just go into email. Those are good. Some developers like that when the battery in their phone dies because they got that many New Relic emails, and there's probably a problem. But in addition to that, let's find a way to get the high fidelity signal on the metric that we actually care about. To come back for the financial audit, what becomes interesting is like once you have that, once you can start counting revenue, once you can start counting things like customers editing orders, canceling orders, that's kind of interesting. And now really the way we solve our financial audit problem is we can create a group, a team in PagerDuty that includes, say, the CFO and the CTO and whoever. And when their alerts fire, that actually is a very rare event. And at that point, we can create documentation that the appropriate people responded. And that's actually kind of the way philosophically that we manage it. I don't think we put that into practice yet at Gilt. But that was really the philosophy, right? High signal to noise ratio on the business metric that matters, get the alert to fire, and then record the action that we take.
There's also an example that actually tackles exactly the question you had. We built, Zookeeper built a service health check which detects what applications we have deployed to production, for each application what host is deployed to production, on what port. And for every application host combination, we'll do a ping on the ping interface. And if your host was down, you would have gotten an eval. This was a year ago. Since Cave, what we did change was that the same service, instead of sending you an email for every host and service combination, would publish a metric for every service and host combination. So then your alerting in Cave, instead of doing when this host has not responded to ping for 3 minutes, you actually had the ability to sum up, to roll those metrics together. So you say, for my service, if I have more than 3 unhealthy hosts, I want to know about it. Or if one host has been down for more than 20 minutes, I want to know about it. So these kind of alerts are very easy to create in Cave, and then they reduce the noise fantastically, because you no longer find out if every time you do the deployment, every node will go out of business for a couple of minutes. You receive 3 emails for 3 nodes, whereas today with Cave, if you have your alerts properly defined, you no longer receive any alerts during deployments. You only find out when stuff really needs attention. Yes, John.
Yeah, just on the kind of the change of mindset as well in creating alerts. So previously we would have had say you've got a page that's serving a product detail screen to the user, and it needs to hit a backend service to get all the detail for that page. And if the backend service is unresponsive, then you want to know about it. When you switch to microservices and you need to hit 30 services to render that page, you're now getting alerted all the time, because there's always going to be one of those services at some point during the day is unhealthy for whatever reason. And you might have built safeguards into your web app that kind of is resilient to those failures. So that becomes really noisy and really annoying. So then you kind of start to think, well, the only thing I really care about on the product page is, are people adding to cart? So now you've kind of switched your alert. Now you've only got one alert, which is these are the number of people adding to cart over the last minute. And then you can start writing your alerts on that, which is completely different from, say, 6 months ago, where you're basically, every time I make a service call and I get an error, I'm monitoring error rates, which is really, really noisy.
And so about New Relic here.
And every time you get an alert, it's like, what team do I contact? It's never my problem. It's always someone else's service.
And actually, this is one thing that New Relic is annoying about, is that every time he sees an exception, you log and think this is an error. But a lot of the exceptions actually are being logged just so that we know that they happened, but they might be recovered later. So there is no way in New Relic to say, these exceptions are important, these are not. And you end up with a lot of red in New Relic, and then it's the same thing that Mike was saying. You just turn off your pager because it's too noisy. And that's the purpose of Cave, was we want to improve the signal to noise ratio so that the alerts we receive are the alerts that map.
We have beer and pizza. We have Val and we have Mike and John here to answer any questions. And we owe you our thanks. Thank you so much, guys.